Good morning. Today we're going to talk about the quadratic formula and solving equations via the quadratic formula. Now, of course, we in earlier sections have solved degree 2 equations and higher with a factoring technique. We're going to expand that to include what we call the quadratic formula. Now, let me write down the section. It's section 10.3 in our text, and the formal title of it is a little wordy, Solving Quadratic Equations by the Quadratic Formula. So I'm just going to call it Solving via Quadratic Formula. Now, the quadratic formula is a well-worn topic in high school. I'm sure we've all seen it before. What it refers to is equations of degree 2. In other words, where the highest power you see on any variable is a 2. All right, so let's give you a standard form degree 2 equation. All right, in other words, I've arranged terms in decreasing degree on the left-hand side and, importantly, equal to 0 on the right-hand side. If I have a degree 2 equation in this standard form, and it's got to be in standard form for this to work, right, then I can write down solutions for x according to a somewhat simple formula. X equals minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. All right, so if I've got enough patience and wherewithal, I can solve an equation for x. I can solve a degree 2 equation for any variable in terms of the coefficients a, b, and c. All right, this is the quadratic formula. Okay, let's jump right in and do an example. I'll do example 1 on page 605. And it says, use the quadratic formula to solve the equation x squared plus 4x plus 3 equals 0. All right, we can see this equation is already in standard form, namely terms are arranged in decreasing degree on the left and equaling 0 on the right. All right, actually I can solve this two ways. I can solve it, of course, by factoring, as we've done in earlier sections. Let me do it both ways. I'm going to solve it by factoring, nothing new in this section really. And then I'm going to solve it by the quadratic formula. And of course, the solutions should be unique. And of course, they should agree. All right. All right, by factoring, well, I can factor that equation. I think x and x in the first slots. Factoring that trinomial on the left-hand side, I'll have x plus 3 times x plus 1 equals 0. All right, I now have a product of factors equaling 0, and I can set each factor equal to 0. And I see a degree 2 equation turns into two simpler degree 1 equations, and I get x equals minus 3 or x equals negative 1. All right, those are my solutions by the factoring technique, again in an earlier chapter. By the quadratic formula, well, if it's in standard form, and it is, a, my lead coefficient, my x squared coefficient is of course 1. My x coefficient, my b value is 4, and my c value is of course 3. So again, the quadratic formula says if you've got a degree 2 equation in standard form, I can say x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay? I just sub the values of 1, 4, and 3 in for a, b, and c respectively. And of course, I'll now want to simplify this expression. Well, x equals, let's go under the radical first and see what I can simplify here. Well, the square root of, well, let's see, 4 squared is 16, again under the root sign, And minus 4 times 1 times 3 is 12. Downstairs, 2 times 1 is, of course, 2. All right, under the root sign, 16 minus 12 is 4. I'll get minus 4 plus or minus the square root of 4 over 2. Now, we of course know that the square root of 4 simplifies to 2. So, need some more room here. I'll get x equals, that square root of 4 turns into a 2. So I'll get minus 4 plus or minus 2 over 2. Now, plus or minus means just that. I've got two options, which will lead me to two solutions in this problem. Minus 4 plus 2 is minus 2 over 2. Or the minus option, minus 4 minus 2, is minus 6 over 2. So finally, I simplify those two fractions. I get negative 1 or minus 3. And notice, this agrees with the solutions that I got by factoring. All right, well, the beauty of the quadratic formula, it seems to be a little more effort to use the quadratic formula, and sometimes it is. It depends on the problem. Sometimes, especially when you can't factor a trinomial expression, you will have to use the quadratic formula to solve. All right, let's jump in and do another example. Let's see, I'm looking at example 2 in our text. All right, I'm not going to solve this one by factoring now that we've convinced us all that the quadratic formula does indeed work. I'm going to say solve this degree 2 equation, 8x squared plus 2x minus 1 equals 0. And I'll say by way of the quadratic formula. Okay? Quadratic formula always works even when the equation or the expression on the left-hand side in standard form does not factor. I always like to write, well, first thing, make sure it's in standard form. Terms are arranged in decreasing degree on the left and equals 0 on the right. So my lead coefficient is A is 8. My B value, my X coefficient is 2, and my C is negative 1. Be sure you include that negative sign. So the quadratic formula says if ax squared plus bx plus c equals 0, then x equals minus b plus or minus the square root of b squared minus 4 times a times c. All over 2a. 2 times a. All right, beware of a couple of things. Let me highlight a couple of things here. Be sure that this root sign swallows up this entire expression, b squared minus 4ac, and make sure this fraction bar swallows up this entire numerator sum or difference. Okay? Otherwise, mistakes may emerge, all right? All right, I'm going to simplify this, and first I'm going to attack the inside of the root expression. 2 squared is 4. Minus, well, minus a minus is plus. I'm going to have a 4 plus then. 8 times 4 is 32. All over 2 times 8 is 16. And I think the worst is over. Under the root sign, 4 plus 32 is 36. Minus 2 plus or minus the square root of 36 over 16. Now, 36 is a perfect square. We know that the square root of 36 is 6, of course. So I can rewrite this as minus 2 plus or minus 6 over 16. And again, I've got to exercise my plus or minus options here, which will result in two solutions. Minus 2 plus 6 is 4 over 16. Well, that simplifies to 1/4. Or minus 2 minus 6 is minus 8, and minus 8 over 16 is negative 1/2. So I've got two solutions, fractional solutions, x equals 1/4 or x equals minus 1/2. I'm sorry, minus 1/2. I made a mistake there. Excuse me, let me correct that. Minus 1/2, okay? All right, let me accentuate that. Let me try this again here, this last step here. If I've got minus 2 plus 6, that's 4 over 16, and that reduces to 1/4, which I've got here. And minus 2 minus 6 over 16, right, that's minus 8 over 16, and that reduces to negative 1/2, which I've got listed here, okay? All right, let's look at example 3 in the book. This is example 3 on page 607. Use the quadratic formula to solve. Well, 2w squared plus 6w minus 3. And I believe this is a situation where the left-hand side is prime. I've got the trinomial expression in standard form, and indeed this does not factor. Kind of hard to tell by looking at it. Well, let's specify the quadratic formula. All right, we are already in standard form here. Ax squared plus bx plus c equals 0. So I can write my solutions for w. Well, hang on. Let me write down what my coefficients are first. All right, in standard form, my a value, my lead coefficient is 2. My b value is a positive 6. That's a 6 there in the degree 1 term. And c is negative 3, of course. All right, so w equals minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, now I can attack this. Well, I'm going to leave everything else hanging for a minute. I'm going to look under the root sign. 6 squared is 36. Minus a minus is plus. 4 times 2 times 3 is 24. So I've got plus 24 here under the root sign, divided by downstairs 2 times 2 is 4. All right, let me continue to simplify that. Radicand under the root sign is a 50. 36 plus 24 is 60. Not 50, 60. Divided by 4. Now let's think for a minute. 60 is not a perfect square. What I can do is break up that 60 and simplify that root. 60 is 4 times 15. So I can rewrite that root expression. The square root of 60 is equivalent to the square root of 4 times the square root of 15. In other words, I can distribute a root sign over a product. Don't forget to divide by 4. W now equals minus 6 plus or minus, well, of course, the square root of 4 is 2. The square root of 15, that can't be simplified any further. Divided by 4. All right, if I now see a common factor of 2 across the fraction bar, I can factor out a 2 from the numerator, and I see 1, 2 in the numerator will cancel out all but 1, 2 in the denominator. So my final answer here, I've run out of room. Hang on, let me make some more room here. Equals minus 3 plus or minus root 15 divided by 2. All right, this represents two different solutions, minus 3 plus the square root of 15, or minus 3 minus the square root of 15. And I leave the answer just like this. I call this exact form, or the simplified root form. All right. All right, I'm going to do a couple of more examples here from the homework list. Let's look at number 38 and the set of exercises at the end of section 10.3. This is on page 312. Another degree 2 equation. I'll solve z squared minus 14z plus 45 equals 0. And again, I'll ask to do it via the quadratic formula. All right, we are already in standard form on the left-hand side, and we've got it equal to 0 on the right-hand side. So I'll write down my coefficients. A equals 1. The lead coefficient is an invisible 1. B equals negative 14. Be a little careful here. And C equals plus 45. Can't really simplify this equation any further, so I'll jump right into the quadratic formula. So z equals minus b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. All right, now these numbers are a little more cumbersome than the earlier examples. I'm not going to panic. Minus 14 is plus 14. Plus or minus, let's look under that root sign. 14 squared, let me get my calculator. 14 squared is 196 minus 4 times 1 times 45. What's 4 times 45? Equals 180 divided by 2 times 1 is 2. So I think we see what's happening here. Z equals 14 plus or minus, well, 196 minus 180 under the root sign is 16 over 2. Of course, we know what the square root of 16 is. The square root of 16 is 4. So I'll have 14 plus or minus 4 over 2. Let's investigate the plus option here. 14 plus 4 is 18. 18 over 2 is 9. Or 14 minus 4 is 10. And 10 over 2 is 5. So I've got two solutions for z. Z equals 9. Or z equals 5. So even with cumbersome values, somewhat cumbersome values, it turned into a pretty manageable expression with a little work. And let's try another one. All right, we're going to look at number 54 on page 612, again in this homework set. We've got this equation. 36 is minus 4s squared plus 40s. All right, now clearly this is a degree 2 equation in S, but it's not in standard form. So that's the first thing I'm going to do is put in standard form. Well, the instructions, let me write that down first. It's to solve by the quadratic formula. All right. You can't use the quadratic formula unless your equation is in standard form. All right, the quadratic formula assumes that. All right. So what I'm going to do is add 4s squared to both sides, and I'm going to subtract 40s from both sides. 36 was already on the left, so I'll get 4s squared minus 40s plus 36 equals 0. Okay? Now, I could jump right into the quadratic formula, but it will make for a nastier expression to simplify. I'll notice every coefficient here is divisible by 4. So can I divide both sides by 4? 0 will swallow up any divisor. If I divide all terms both sides by 4, I'll get somewhat less cumbersome values to deal with when I plug into the quadratic formula, and that's always a good thing. So yes, this is in standard form, and yes, I've divided by all available common factors. So I'll say my A value, my lead coefficient is 1, my degree 1 coefficient is a negative 10, and the constant coefficient is positive 9. So then plugging into the quadratic formula, S equals minus B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right, let me look under the root sign here. I'm going to attack this pretty much first. Well, minus 10, I can take care of that along the way. That's positive 10 plus or minus the square root of, well, minus 10 squared is 100. Minus 9 times 4 is 36. Well, that radicand turns into a 64, does it not? 100 minus 36 is 64. Divided by that whole mess divided by 2 times 1 is 2. All right, again, make sure that fraction bar swallows up that entire numerator sum and difference. The square root of 64, well, we know the square root of 64 is 8, so I'll get 10 plus or minus 8 over 2. So S equals 10 plus 8 is 18 over 2, or the minus option, 10 minus 8 is 2 over 2. So I've got two solutions for S. 18 over 2 is 9, or 2 over 2 is 1. So S equals 9 or 1. All right, let's talk about one more and we'll call it a day. This is again from the homework list. This is number 41. 41 says solve this degree 2 equation in y, this time 2y squared minus 7y equals negative 4. All right, this indeed is a degree 2 equation. And degree 2 equations can be solved by the quadratic formula always. All right, but I've got to get it in standard form first, right? I've got to add 4 to both sides. So let me make a note of that. Put in standard form. And of course, by standard form, I mean ax squared plus bx plus c equals 0. Degree terms arranged in decreasing degree on the left and equaling 0 on the right. If you're not in standard form, you can't use the quadratic formula. All right, so all I've got to do here is add 4 to both sides. 2y squared minus 7y plus 4 equals 0. My lead coefficient is 2. My degree 1 coefficient is negative 7. And my constant coefficient is, of course, 4. So I get y equals minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, now let me simplify this as much as I can. I get y equals minus 7 is 7. Plus or minus, what's under the root sign? Minus 7 squared is positive 49. Minus 4 times 2 times 4, well, I get 16 times 2 is 32. Right? 49 minus 32 under that root sign, divided by downstairs. The denominator is 2 times 2 is 4. All right. The worst is over here, so I'll write y equals 7 plus or minus 49 minus 32 is 17. Now the square root of 17 can't be simplified. I'm going to have to leave it just like that. I'll get 7 plus or minus the square root of 17 over 4. All right, and this represents two solutions with the plus or minus option. And again, I call this answer, some books call this the exact form, or some books call it the simplified radical form or simplified root form. All right, when your radicand is not a perfect square and can't be simplified any further. All right, we've done plenty of examples today, so we'll call it a day. This concludes section 10.3, Solving by the Quadratic Formula.